In this video, we are going to see one of the most important components in modern electronics, that is the transistor. If you are working with Arduino, embedded system, robotics, then understanding the transistor is extremely important because in today's world, the transistor is exists almost with every electronic components. In this video, we are going to specifically see the BJT, means bipolar junction transistor. We will see how BJT works, the current gain formula, the mode of operation of BJT, and the application of BJT. So let's start. Firstly, we need to understand what is the transistor. The main function of the transistor is switching and amplification. In amplification, the transistor can control a very high amount of output current by giving the very small amount of input current. Due to this property of transistor, it is used in almost every electronic components that we are using today. The transistor is used in our PC, laptop, computer, electronic devices, robotic components, etc. In fact, in the modern processors, in the modern CPUs and GPUs, there are almost billions and billions of transistors used. So, without the transistor, the modern electronics would not practically exist. Before understanding the working of the transistor, we need to first see what is the semiconductor. So basically, semiconductor is a material which is not a perfectly conductor, not a perfectly insulator. Its conductivity lies somewhere in between. Such type of material is called as semiconductor. Basically, we use silicon as our semiconductor because its conductivity lies somewhere in between. If we add some impurities to the semiconductor, we will get a two different types of semi. We will get two different types of semiconductor that are p-type semiconductor and n-type semiconductor. In the p-type semiconductor, we measure the charge carriers, and in the n-type semiconductor, we measure the charge carriers on electrons. If we connect these two different types of semiconductors, we will get a p-n junction die. But if we connect with another p-type semiconductor, in this n junction, we will get a PNP transistor. First, like that, if we connect n type of semiconductor at the end of the p-type, we will get NPN transistor. So now we are going to see what is the PNP and NPN transistor. Now the BJT stands for bipolar junction transistor, and there are only two types of BJTs, NPN and PNP. And there are three terminals of it: base, collector, and emitter. The base terminal acts as a control terminal of the BJT, and the main current flows from the collector to emitter. Now we are going to see the working of BJT. Now we'll see the working of the NPN transistor because NPN transistor is mostly used in the electrical circuits. In the initial stage, when no current is applied at the base terminal, therefore IB is equal to 0. In this state, the transistor remains in off condition. It means that no current is flowing from collector to emitter. And in the next state, when even if small amount of input current is applied at the base terminal, the very large amount of output current is flowing from collector to emitter. This is the most important property of transistor, that even if you apply a very small amount of input current, it will drive very large amount of output current. This is because of the current gain. Now we'll see the concept of current gain and how it works. The main idea of current gain is a small amount of input current will control the large amount of output current. The formula for current gain is IC equal to beta times IB, where IC is collector current, IB is base current, and beta is the current gain. Let's take an example. Suppose our IB is 1 milliampere. The current gain is suppose 100, and we have to find the IC. So by using this formula, IC will be 100 into 1 milliampere is equal to 100 milliampere. It means that the collector current is 100 times larger than the base current. That's why the transistor can control the high amount of output current by using the small amount of input current. Let's take an example of microcontrollers like Arduino and STM32. The output pin of any microcontroller contains a very small amount of output current. But our relay, motor, and high power electronic devices needs a very large amount of input current. By connecting them directly can damage the microcontroller. By using the transistor, we can connect them directly and safely. Now we'll see the modes of operation of BJT. There are three modes of operation in any BJT: cutoff region, active region, and saturation region. Firstly, we'll see the cutoff region. The electrons in the N terminal require minimum of 0.7 volt of input voltage to travel from N terminal to P terminal. So, if the input voltage, that is the VB, is less than the 0.7 volt, suppose the VBE is less than 0.7 volt, therefore no electrons can travel from N to P terminal. It means that IV is equal to 0. And if the IV is equal to 0, then no current will be flowing from collector to emitter. It means that IC is almost equal to 0. Therefore, in this region, the transistor would act like as an open switch. It means that no current will flowing from collector to emitter. Now next is active region. In the active region, the input voltage becomes exactly 0.7 volt. It means that the electrons of the N terminal can travel to the P terminal. Therefore, the input current, that is meant by IB, becomes slightly greater than 0. If the input current, that is IB, becomes slightly greater than 0, then the collector current becomes beta times IB. It means that even a small amount of input current, even a small amount of base current can control a very large amount of collector current. But in this condition, the transistor is not fully on because the collector current is fully dependent on the base current. If the base current increases, then the collector current increases. If the base current decreases, then the collector current decreases. This region is mainly used in the amplification systems such as radio amplifier, audio amplifier, and amplification circuits, etc. The next region is saturation region. In this condition, the base current becomes so high that the collector current reaches to its maximum value. Therefore, the transistor is acting like a full open switch. In this condition, the current can easily flow from collector to emitter. But in this condition, even if we further going on to increase the base current, the collector current will not increase because the transistor is already fully on. This type of region is mainly used in motor control, LED switching circuits, and relay driver circuits, etc. Now, let's take a summary of it. In the cutoff region, the transistor is in off state and it is used for switching the circuit off. In the active region, the transistor acts like an amplifier and it is used to amplify the signals. In the saturation region, the transistor is fully on and it is used for switching the circuit on. So this is the complete beginner friendly explanation of how BJT works. I hope you understand what is BJT, how BJT works, what is the current gain, and what is the modes of BJT operations. So thank you for watching this video.